Good day. Quickly do the calculations, which will be visible on your screen just now, and then we will mark it in just a second. Grade 9s. Let's quickly mark the calculations. First question. Minus 2x to the power of 4, y to the power of 5, multiplied by minus 4x to the power of 3 times y. And in the denominator, we have 2xy squared in brackets, but it's to the power of 5. What can we do with that? Or let me ask this. How many terms do we have in total here? We actually only have one term. Okay, so how will we handle that? Let's multiply our signs first. I have a negative times a negative, and a negative times a negative becomes a positive. You can write it or you don't have to. It doesn't matter. I am going to write it just to make sure that you know that it's now a positive sign. Now the numbers. 2 times 4 is 8. 2 times 4 is 8. And now we go to the variables. But remember, I have a base x and a base x. Bases are the same. They are being multiplied. So what do I do with my exponents? You add them. X to the power of 4 plus 3 is 7. The y's, let's do the same. Y to the power of 5 times y to the power of, actually 1. Add the exponents, so we will have y to the power of 6. Y to the power of 6. And in my denominator, what do I have? Remember, I have a bracket with an exponent 5 there at the end of the bracket. So what do? Rule number 3. The exponents on the outside of the bracket should be multiplied with the exponents on the inside of the bracket. So currently the 2 is actually to the power of 1. So if I multiply those exponents, it will be 2 to the power of 5. Next one, the x. I have it as to the power of 1. So if I multiply the 5 with the 1, it will be x to the power of 5. And then the y. Y to the power of 2, multiply those two exponents, and I will have y to the power of 10. And now we can cancel out, or actually we are applying the first and second law of exponents. Let's have a look. The numbers, let's deal with that first. I have an 8 here, and in my denominator I have 2 to the power of 5. Do you know what's 2 to the power of 5? Please don't tell me it is 10. You never ever multiply those two together. It is 2 times 2 times 2 times 2 times 2, and that is actually 32. So 32 in my denominator. Now let's deal with the x, the base x. I have 7 x's in the numerator. I have 5 x's in the denominator. If I cancel out, what will be remaining? 2 x's where? In the numerator. So it's x to the power of 2. And now the base y. I have 6 in my numerator and I have 10 in the denominator. If I cancel them out, what will be remaining? 4 in the denominator. So it is y to the power of 4. And now, boys and girls, the only extra thing that you can do here is you can simplify the 8 over 32. You can divide it by 8. So I can say 8 can go into himself once. 8 can go into 32 4 times. And my x squared is still in the numerator, and my y to the power of 4 is still in the denominator. Did you get it like that? I hope so. Have a look at number 2. X squared plus x to the power of 4. What should we do? Bases are the same. They are being added, not multiplied. And because they are being added and not multiplied, you cannot apply the rule or your law of exponents, boys and girls. Can I do anything here? No, they are not like terms. I cannot say it is x to the power of 6. Please be careful. So this one stays the same. I can say it is x squared plus x to the power of 4. It stays the same. Number 3. 3 in brackets minus b to the power of 4 and with a square outside times 2 brackets minus b to the power of 3 and the exponent 3 outside again. What should we do first? According to BOTMAS, let's deal with the brackets. Now, inside the bracket, I cannot do anything there. So I need to now go to the orders. And the orders here is actually my exponents. It's to the power of 2. So I can multiply my exponent and at the outside with the exponent on the inside. But careful, I have a negative sign there as well. So I have 3 bracket. So I need to say a negative times a negative, and that will become a positive. Positive b to the power of 8 times 2 brackets. This one, it's to the power of 3. A negative times a negative times a negative becomes a negative or stays a negative. So it's negative b and now to the power of 3 times 3, 9. Okay, and now I can apply my first law of exponents. Let's multiply the 3 and the 2 first. 3 times 2 will be 6. A positive times a negative stays a negative, so the negative will become in front of the 6. And then bases are the same. It's b times b. Add your exponents because they are being multiplied, the bases. So 8 plus 9 will give me b to the power of 17. Did you get it like that? I hope so. Let's have a look at question number 4. Question number 4, quite similar, but there's actually one big thing that's different. Can you see what it is? Yes, it is the negative exponent there. Now, boys and girls, can you remember when we talked about the rules or the law of exponents, that if I have a negative exponent and this bases are in the numerator, I can take them down to the denominator. And if I have a negative exponent in the denominator, I can bring up the base with the exponent to the numerator, and then the sign will change. And this is what I'm going to do here. While I'm doing that, or I'm working towards that, I am also going to simplify this. So I have 3 third law of exponents. It's to the power of 1. You need to multiply the exponent outside with all the exponents inside. So it will be 3 to the power of 2, x to the power of 10, and y to the power of 2. Then this one now, I have a power of negative 4, and I'm going to take it now to my denominator. So then it will be 2x cubed y squared, and to the power of positive 4. Well done, to the power of positive 4. And now I can simplify my denominator there. So my numerator, I can say 3 squared. It will be 9, x to the power of 10, y squared. And in my denominator, I will have 2 to the power of 4. What is 2 to the power of 4? 16. 16. My x's, x to the power of 12. And the y's, y to the power of 4 times 2, 8. And now I can cancel out. Is there a number that can both be divided into, or can both go into 9 and 16? No. So it will stay like that. And my base x, I have 10 in the numerator, I have 12 in the denominator. So if I cancel out, what will be remaining? 2 x's in the denominator. X to the power of 2. And the y's, I have 8 in the denominator and 2 in the numerator. Cancel out. What's remaining? Y to the power of 6 in my denominator. Right. Now, boys and girls, because you are grade 9, you are also doing exponential equations. And let's have a look at it. The question there will be that you need to solve for x, but you need to understand what it means. It's important that you understand what it means before you try to apply a rule. Here I have 3 to the power of x equals 9. Now, if you would like to figure it out logically, you can say, okay, wait. 3 to the power of 1. 3 to the power of 1. What is 3 to the power of 1? It's 3. Okay. And 3 to the power of 2. What is 3 to the power of 2? It's 9. Okay. And 3 to the power of 3. And that will be 27. And so on. But look here now. I have a 9 there. So then I can go and substitute the 3 squared that I have here, that's equals to 9. I can go and substitute it into that place. So I will have 3 to the power of x equals 3 squared. And boys and girls, once I have my bases now the same, and I have one term on the left-hand side of my equal sign, and I have one term on the right-hand side of my equal sign, then I can say, okay, I'm not going to write the bases anymore. I can say x equals 2. Let's do a couple more. The next one, question number 6. I have 7 to the power of x equals 1/49th. Okay? Is there something familiar of the values that you see there? Are there something familiar? The 49 is actually 7 squared. Now let's change the 49 to a 7 squared. So I have 7 to the power of x, 1/7 squared. And now, boys and girls, similar to what we did earlier, I have now my 7 squared in the denominator, but I want it in the numerator. Do you remember what we did here when we had a -4 in the exponent there? And we moved it down to the denominator, and then we've changed the sign of the exponent. So, boys and girls, that's what we can do here. Exactly the same. I have a 7 squared in the denominator. So if I move the 7 squared up to the numerator, what will the sign become of the exponent? The sign must change, so it will be a negative square. Let's have a look. So 7 to the power of x equals 7 to the power of -2. And now I have one term on the left-hand side and I have one term on the right-hand side. So what can I, and they're the same bases. So what can I do with my bases? I can ignore them and I can only write x equals -2. Therefore, x equals -2. Number 7, have a look here. 3 to the power of x plus 1 equals 1. We have a bit of a problem. Do you see the problem? We don't have a base 3. So I cannot leave my bases and only write the exponents because I do not have a base 3. Oh dear. Can't we maybe change the 1 to become a base 3? What do you know about anything to the power of 0? It is 1, except 0 to the power of 0. That's undefined. But anything to the power of 0 is 1. So I can reverse that by saying 3 to the power of x plus 1 will be the same value as 3 to the power of 0. 3 to the power of 0. And boys and girls, careful with this because the teachers love it to put it into tests, okay? Right, so I have now one term on the left-hand side, one term on the right. My bases are the same. I can leave them out and just say, you know what? X plus 1 is 0. And what will be the answer or the value of x? X will be -1. 1. Thus, x will be negative 1. Okay. Number 8. Again, a quite interesting one here. 3 times, it's not decimal, it's times. 3 times 2 to the power of x equals 96. I have one term on the left-hand side and I have one term on the right-hand side, but are the bases the same? Can I say 3 times 2? No, please don't, because then you're not applying the laws of exponents anymore. The bases needs to be the same. They are not. What's the exponent of the 3? It's a 1. So, can't I say divide by a 3 both sides? Yes, divide by a 3 on both sides. So, I will have divided by a 3 there. So, 2 to the power of x equals, what is 96 divided by 3? 32. That's better. And if you know your exponents, you will know that 32 is something to the power of something. It's 2 to the power of 5. So 2 to the power of x equals 2 to the power of 5. Thus, my answer of x will be 5. Boys and girls, let's have a look at the last calculation. And careful, because this is a calculation that teachers also love to ask. Let's have a look at it. 5 to the power of 2 times 5 to the power of x plus 2 equals 125. How does it differ from the previous one? Can you see that? Here I had 3 times 2 to the power of x, but here I have 5 squared times 5 to the power of x plus 2. It's all about the base. Okay, the bases are the same. And because bases are the same and they are being multiplied, do the first law of exponents. Add the exponents. So I will have 5 to the power of 2 plus x plus 2. And now the 125, you need to know by now that 125 equals 5 to the power of 3. Equals 5 to the power of 3. And now bases are the same. I have one term on the left-hand side and I have one term on the right-hand side. So I can leave the bases and only write the exponents. So thus 2 plus x plus 2 will give me an answer of 3. And if I simplify that, x plus 4 equals 3, x equals negative 1. Did you get it like that? I hope so. Boys and girls, I hope that you understand exponents now a lot better. And please stay with your teacher and ask them if you do not understand. Until next time, goodbye.